The objective today is to explain what makes a good versus bad password. So last time we talked about the Visionaire cipher. This was a pretty fun widget that we could use on code.org. To start today, I want you to compare and contrast the difference between a substitution cipher and a Visionaire, that is the cipher we looked at last time where you had a key and the key gave us the details as to what substitution would occur. And I want you to do this comparing and contrasting with the following message. I think I can, I think I can, I think I can. To explain why this Visionaire is a stronger form of encryption than a substitution cipher. To achieve this, all you have to really do is answer this think, write, share. Will frequency analysis work to crack the Visionaire cipher? Why or why not? And here's a hint. In cryptanalysis, frequency analysis is the study of the frequency of letters or groups of letters in a ciphertext. The method is used as an aid in breaking classical ciphers. Frequency analysis is based on the fact that in any given stretch of written language, certain letters and combinations of letters occur with varying frequencies. Moreover, there is a characteristic distribution of letters that is roughly the same for almost all samples of that language. So for instance, given a section of English language, E, T, A, and O are the very most common, while Z, Q, and X are rare. When you created your password, the site may have presented you with some rules for your password, such as it must be 8 characters long, contain a number, contain in uppercase or lowercase letters, or it must contain some sort of a special symbol. My question for you is, based on what you know about how keys work in cryptography, give a reason for why these rules require A, a certain number of characters, and B, a mixture of letters, numbers, and symbols. So you're doing a lot of writing to learn today. Bear with me. Your challenge, think, write, share here, totally optional, is it is easier to crack a message if you know that it was encrypted with the Visionaire cipher widget and that the key was 10 characters long. So anyone in class in need of extra credit might want to really tackle that question. So time for some fun here. Check out how strong your password is by going to howsecureismypassword.net. This site could be stealing your password. It's not, but it easily could be. So be careful where you type your password. We all heard of the situation in Hawaii where citizens were getting an emergency alert about incoming missiles. Well, come to find out, one of the people who work in that emergency center, they had their password for that program right on a sticky note on their monitor, so anyone who saw the picture could have zoomed in and saw that password, even with the bad handwriting, figured out what the password was, and thus send out crazy messages like that. So just for future reference, when I give you a website for you to just enter in a password, maybe don't use the password you use for your banking, because maybe I'm just doing some phishing, maybe I'm just stealing that password for myself, which obviously I am not, but I'm also warning you, so don't use that password on that website. So here's 3 reasons why the Visionaire cipher is strong. Because looking at the ciphertext, there are no discernible patterns. So assuming a good key was chosen, you shouldn't be able to detect any patterns like that. Because the ciphertext is resistant to analysis, it leaves us simply having to guess what the key is. So that's the second reason, just simply guessing is involved. And the third one is, even if we know the length of the key, we might still have to try every possible letter combination, which is prohibitively large number of possibilities. So depending on your computing resources, that will be pretty tough to do. My advice when it comes to passwords is the most important element to passwords is its length. The longer, the better. So for a long time, the Visionaire cipher was considered to be an unbreakable cipher and was used by governments to send important messages. But in the 1800s, Visionaire was discovered to be susceptible to a modified form of frequency analysis. After that point, it was considered insecure. We know that good encryption algorithms reduces the problem of cracking it simply by guessing the key. We want the key to be computationally hard to guess. In other words, hard for a computer to guess. Computationally hard typically means that arriving at the solution would take a computer a very long time to do, maybe centuries or eons. In terms of cracking encryption, that means that the number of possible keys must be large. Just like I said, the importance is in length more than any of those other things you read in creating a password. So even a computer trying billions of possible keys per second is unlikely to arrive at the correct key in a reasonable amount of time. Nowadays, when you use a password for a website or device, your password is used as a cryptographic key. So choosing a good password is meaningful because we want the key to be hard for the computer to guess. Think right, share. What does computationally hard mean? Why might it actually be a good thing that encryption algorithms are freely shared so that anyone who wishes can try to crack them? Remember, this concept was in a previous lesson. If the security of an encryption technique relies solely on the method remaining a secret, it actually may not be that secure. People in cybersecurity call this security through obscurity, and it's typically frowned upon. Ideally, a method will be so secure that even if you know which technique was used, it is difficult or impossible to crack the message. By making encryption techniques public, we open them up to being tested by anyone who wishes to ensure there are no clever ways of cracking the encryption. We're circling in on some powerful ideas of how secure communication works on the internet these days, but we need to learn two more things. We've seen how keys relate to the strengths of encryption, but we haven't seen the other side of it, how modern encryption algorithms actually work. Visionaire was cracked, so what are we using now? In order to do this, we need to understand what kinds of problems are hard for computers to solve. Right now, the only encryption we know uses a symmetric key. Both sender and receiver need to know the secret key, and so they need to meet ahead of time. So if I say symmetric key, what I'm saying is that both sender and receiver need to know the secret key. Thus, they are symmetric. The key from the receiver is the same key from the sender, and that's very hard to do. They have to meet secretly and then not share that information. So here's the mind-blowing part. It is possible for you and me to have a secure, private, encrypted exchange without ever meeting ahead of time. So after you are done answering the DOL, if you have time in class, I want you to check out this article. It's definitely worth your time. It's titled, How Not to Get Hacked. And don't worry, we'll go more in detail as to how asymmetric encryption works. So bear with me, there's a big writing day, but the more I read your thoughts, the more I know if you're understanding the complexity of security. So three think right shares here. Companies and organizations commonly require users to change their passwords frequently. Websites have password length and complexity requirements. Is it better to change your password frequently or to have a longer password? What level of security is appropriate to require of end users? That is, how much should I ask of you, the person visiting my website, to do? Does this change depending on the context? So, for example, if you're an employee of a company, maybe in my example, I have different password requirements to get into my email from Harrison District 2 than I have in terms of having a password with Gmail, a personal. I'm just a customer of Google there. So thus the requirements really are different. So yes, a lot of questions there, but please, I'm looking forward to reading your thoughts to get a good feeling as to if you understood the lesson. So your IB, fill in the blank for the day. This is the type of lesson that would be a characteristic of which profile attribute. And then here's the DOL, which makes for a password that is hard to crack. A word from the dictionary. B, 8 random characters that include numbers and punctuation. A 16-character password that is all letters of the alphabet. A 32-character password that is all letters of the alphabet. Or a 150-character password that is all the same exact character. Okay, and here I want you to add a reason why. If you just put A, B, C, D, or E, I'm going to give you no credit at all, even if you got the right letter right. And if you're listening to this instead of just reading it on the screen, I have provided you a pretty big hint here.